So welcome everyone to our talk on building a package with assets. I hope you're in the right room. So I'm Moritz, I'm a software engineer on the Dart ecosystem team, and that's Daco. You probably already know him from the Dart native interop team. So first, a warning, most of the stuff we're going to show you is a varying degree of experimental, like some stuff works behind an experimental flag, that's the most stable stuff. Other things only work on some OSs, also behind experimental flags, and other things work only on my current local branch. So, yeah. Okay, so first of all, like, why do we actually want assets in the first place? Because, I mean, we have Dart code, we all like Dart code, but there's still some things that are missing, right? Like, I mean, we might want to have our favorite packages from Rust, from C, which we don't want to re-implement in Dart. So we just want to be able to use those. And that's what we call native assets, or native code assets. But we also have like files which we want to use. This is a feature which exists kind of already in Flutter to some degree. You can add like media files or pictures or JSON. By the way, JSON also has a logo, but I've never seen it before, and I suspect that nobody else does, so I rather wrote this down. Yeah, and so we want to add all of this, but at the same time don't get any of the drawbacks that come with it, right? Like if I would to import OpenCV or something, I would have this gigantic file. If I have like different images for my for different logos for different OSs, then I have like a bunch of assets which I actually don't need. So Daco.
Yes. So the high-level idea that we've been thinking about with assets is kind of like a three-step journey. A three-step journey where the first thing that you want to do in your package is declare what assets you have. So this is kind of analogous to like the assets in Flutter, where you have like an assets colon in your pub spec. But this is not very flexible. So the thing we're envisioning is this thing called a build hook, which is a hook that will run whenever you do Flutter run, Flutter build, Dart run, Dart test, Flutter test, all these commands, they will run this hook. And this hook will build your assets. So if it's a C library or a Rust library, you will run the native build or download your library from a content delivery network. Or maybe you're building a game engine and you have some kind of like model files, and those model files are your sources, and you need to compile them to some binary format in order to ship them with your app. You can run your like model file compiler. Then the second step is tree shaking, and tree shaking is only a step that will happen if you do like a Dart AOT compilation, so that's Flutter release or Dart build. And that analyzes all of your Dart code. It checks what Dart code is left over after the whole package, the whole application is analyzed. And then all the other Dart code is thrown out. Now, if you use assets, but your assets are only used in the part of the code that's thrown out, you want those assets to be thrown out so that your Flutter app becomes smaller. So that's where tree shaking comes in. And then the last step is using your assets at runtime. So that can either be native code assets and you do an FFI call to some native library, or it's some data asset and it might be like a JSON or an image and you want to load the bytes or you want to load it as a string. And so that's the last part of this journey. And now it's time for Murphy. So now we're going to go to the demo. So first demo I want to show. Is this big enough for everyone in the back? Can you read this? I see some nodding. Good. Oh, I see some non-nodding. Okay, good. I'll make it bigger. Okay, I have a my package here, which I'm gonna remove. So now we're gonna pray that all of this keeps working. So first thing, you're gonna need to do Flutter channel master to be on the master channel, and then Flutter config. Enable native assets. And that's one thing you need to enable these new hooks. Now, I already did this, so this didn't change anything for me, but that might mean that you need to restart an editor. And now the next thing, if you want to play around with native code assets, you can do Flutter, create, template, package, FFI. Now, package FFI is different from plugin FFI. So plugin FFI is the old way to use native code, which generates like Gradle files and CocoaPods files and all kinds of native build files. Package FFI is just a Dart package. There's no Flutter plugin, there's no native build files, there's only a build hook. So we're going to call this my package. And just please make sure that you don't all use the Wi-Fi, because otherwise stuff will break now. And then, okay, we will go cd my package. And then I will open this in VS Code. And I will probably have to run pubget, flutter pubget, just to make sure that all of the stuff works. All right, let's see. So first I will show you the hook, because that's the first part of including some native code. So we have a hook here. Almost fits on the screen. So the way that these hooks work is these hooks are different from something that you would put in your bin folder or your tools folder. So like your bin folder is your public command line API for whoever uses your package. But any script that's in your bin folder can have an arbitrary command line API. Right? Your tools folder will be whatever is your own command line utilities that you use while developing the package. But the hook folder is a predefined folder where we have some predefined files, for example, build.dart, that have a predefined command line interface. So if this file exists, the Flutter and Dart tools will call this file with specific command line arguments and expect a specific output. So the arguments that are being passed in are being parsed by this helper package, which gives us access to a build config, because it's a build hook, and then we can write output to the build output. And because we don't want to really do this by hand, we have a helper library for C libraries. For data assets, you probably would do it by hand, but we can show that later. The helper library that, in our case, just compiles some C sources. So we have our favorite native code that you probably all have seen before. It's a sum function, because we don't want to re-implement sum in Dart. Which has a very particular implementation. It returns a plus b. Unless you're in debug mode, then it returns a plus b plus 1,000, which is great if you want to write unit tests, because now half of the time your unit test fails. So we're going to build these C sources. And here we have a thing called asset name. And that's for where your asset is used. So if we go here, we go to my package generated, which is generated by a tool called FFI-gen. So you point it to your C header files, and it will generate Dart bindings for it. We can see our sum function here. And this at native annotation means it's connected to the native code asset that's being created in the build hook. So let's go to the terminal here and just say Dart test. Oh, that's great. No such file or directory. Dart test. Okay, so in Flutter, you enable experiments by setting the config. In Dart, you do it by passing a flag. So I'm going to have to pass a flag here. Say Dart enable experiment native assets test. And now this will take a while, because it's going to invoke the C compiler to compile the C code and run the test. And I promised you that my test would fail, because the test is run in debug mode, and we were expecting 42 as an answer, but we got expecting, wait, maybe the test is running in release mode now, the fact that our test is failing. But that's just to show you that this is integrated in Dart tests, and is the same for Flutter. So if we go to the Flutter example app, because this Flutter template still creates an example app, we can do Flutter run the macOS. And then Let's see if Murphy is happy with us or not today. Suspense. You know, Flutter is great. You never have to wait on compilation. And I could have, of course, cheated and did this before, and then everything would be cached, but that would be cheating. Okay, so we did something. Here we go. This is my favorite app, Flutter app. This is also the only Flutter app I have ever created, because the only thing I do is test foreign function interface features. All right. So we looked at the build hook, and we looked at how this is used from libsource. One thing that we can do here, just to show you some of like the use cases if you're using native code, is we can say like we're going to add a new function. Let's say we're going to add multiply. Let's say we don't care about debugging nowadays. Who needs to debug their code? So this is our implementation. And then we also need a header. Multiply. All right. Now I'm going to go back to my terminal. And I'm going to do flutter pub run ffigen config. So I think it's -- config. ffigen YAML, which now takes the new header file and generated new bindings. So now we should have a multiply function here. Yes, you see there's no comments here because I didn't bother to write comments in my C header file, so there's no comments in the Dart bindings, which is not that useful, but we'll run with it for now. For some reason, we're forwarding all the code here, so I'm going to just make a function here, multiply, and then I can go to my Dart example app and then say, instead of running sum, I'm going to run multiply. And then, of course, sum results should be renamed. Rename. And multiply. And then we should be able to run our code again. Let's see if it works. Here we go. So now we are multiplying 1 and 2 instead of adding 1 and 2. Of course, for adding and multiplication, you wouldn't really want to write your code in C, but you want to use this for existing C libraries such as SQLite or some kind of image processing or your favorite AI library. One other thing I want to show you before we go into link hooks is that this is. Let's see. Need to check where this example project is. See. Yes. Let's do the Flutter package. One of the reasons why we made this a protocol is so that it's not necessarily tied to one specific programming language. So in here, we have a build hook that, I guess it needs to be bigger, that instead of using the helper package native toolchain C, it uses native toolchain Rust, which wraps the Rust compiler and has a Rust builder, and then compiles it Rust. And then in exactly the same style, it will call the Rust code. So if we go to the example here. I can do Flutter run the macOS. And I updated my Rust compiler yesterday, so this should actually compile now. Which is summing two values in Rust. Let's check that that's actually what it's doing. Lib main. Yes, we're summing 10 and 15 in Rust. So this is how you can use the same build hook to compile Rust code. And one of the advantages that this has over the Flutter plugin system is that there are no Gradle files here. There's no Cocoapot files. This works with any platform, and it also works in Dart standalone. So you could, for example, think about, we have a package called package HTTP, which is being used in Dart standalone and in Flutter. And well, we can't really go and make this a Flutter plugin because it would break all the existing Dart standalone uses, and this enables us to do that. And I think that brings me to the end of my part, and we will now look at link hooks and tree shaking.
Okay, let me make this a bit larger. Okay, so I'll continue where Daco left off earlier with the C example. And so what we have here, again, is very similar to what Daco showed earlier, but this time we have two C libraries. One does adding and one does multiplication, add and multiply. And so the other structure is almost exactly the same. You have the generated bindings, and you have this, these helper API around it. And in the build, again, it looks kind of similar. But what we want to do now is we have, as you see, a link.dart. So what we have is here we only use the add function. So ideally, we wouldn't use the multiplication. Because we don't use the multiply function, we want to remove it from our dynamic library, which we will generate. So we add a link, which was after compilation. And in this link, let me shrink this left bar a bit. In this link, we now will tree shake our library and use only the add symbol, right? So what we are doing now is we need a static library for that, because we will use a linker to compile this into a dynamic library. So in the build step, what we do differently is that if linking is enabled, we will have a static library generated. Otherwise, everything stays the same. So let's check if this works. So we will now use the native assets experiment again. I also enabled this record use, but we actually don't need this now. And we will build our Dart app. And this now builds something in here with a library, the SO, and let's check in the list of symbols. And indeed, it's only the add in there. So the multiply got removed, which is great. Everything works well, or I mean, we can also check if it works well, actually. Yeah, this all seems to work. But it's still not ideal because we have to, I mean, it doesn't really work because we are still have to, in our link hook, specify ourselves that we only use the add method. And I mean, we know that we only use the add method, or Dart knows, because there's no mention of multiply here. So what we actually want to happen is that here we don't have add, we just have like the symbols being recognized somehow automatically. And for that to work, I will now, because I'm lazy and I don't like typing so much on a stage, I will just apply my stash. And now magically it all works. So what we basically do is we add this record use annotation to the methods. And this means that these methods should be recorded. Their usage should be recorded. It's an annotation in package meta, and we added it to our add and our multiply method. And in the link.dart, we add the identifiers for our add and multiply methods, and then we say, okay, like check if there are any arguments to the method. If there are, then we know this method was called, so then it's like part of our symbols. If it's not, it's not. So again, and so that you know that I'm not cheating, I will delete the cache. And let's run this thing again. And this now needs this record use experimental flag. Okay, so this generated something again. Let's again check if it works. It works, and let's check the symbols. And again, it's just the add symbol. So it recognized that we only used the add method. We didn't use multiply, so multiply is tree shaking out. And that way you can take like a huge library with tons of symbols and you only use one of them, then everything is tree shaking out. Caveat, this only works on Linux at the moment. If you are a fan of implementing different linker flags and mapping linker flags on different OSs, like, please contribute. And that concludes it for our demo for native code assets. What we want to look at next is data assets. So let me close all of these. So for data assets, we have a very simple example here. I have like some assets with premium content, which is very nice, and standard content, which is only kind of nice. And now I want to add this content in a Dart app, which currently wasn't possible. Now we can do that. So I have a build hook where I have a asset builder, which we can add a string asset with a name and some file. Yeah, that's like as simple as it gets, right? And then in my file here, I check if I'm in the premium version. Let me check if I am actually a premium customer or not. No, it turns out I'm not. I was too cheap to pay. And now I can either load the premium content or the standard content. So I know already, because this is constant again, that I will not use the premium content, right? So let me clear this and go into my linking example. So ideally, I know if I now compile this, let me do this. Yeah, if I now run this linking example, it should show, yeah, kind of nice content because I'm not a premium user. And if I build it, then it should only build link bundle, that's the word, it should only bundle one of them. And indeed it does. It only bundles the standard content because it knows that the premium content isn't used. And this all happens, if you're interested in the like gritty details, it all happens in the, let me get the right file. This is like the information which is stored, like in this usage recording, it stores that I only use the standard content and there's no mentioning of premium content here. And this is all made possible by a new package, which hopefully in the very near future will also work on Flutter, which is package asset, which provides this string asset functionality. And as you've seen before in the other example, string asset is annotated with record use. So it records the usage of your string asset instances and yeah, can then tree shake accordingly. The main difference to how the Flutter asset system works currently and how this works is, of course, that for this to work, you need to know what arguments are passed at compile time. So using something like, I don't know, arguments.first here, arguments.first, this is not const, so it can't work because the tree shaker couldn't possibly know what kind of asset you use there. But other than that, all works fine. I only have the assets bundled that I need, so in the future I can hopefully, if I have my Flutter app, I can just like basically add all the assets that I need or think I could ever need, and then everything will just magically disappear and leave me with like a tiny version, both for the native code assets and for the data assets. Yeah, that's it for the demo. That's wrong. Let's go back into this slideshow. Yeah, and that's you again.
It's me, Mario. All right. So, what's the current status of this? The native code assets are in experimental. They're still behind an experimental flag because there's a bunch of implementation details that we are considering changing because we want to be able in the future to make sure that we can add things that we want to add. We want to make sure that this works in all kinds of use cases. So for example, think about you have your hook that builds some C code, and now you do Flutter run in one terminal, and at the same time you do Dart test in another terminal. What happens there? So there's a lot of corner cases there that we need to cover. So that's why it's still an experimental. So the build hooks and link hooks, they're an experimental, and then the native annotation that uses the code assets, they're also available behind the same experiment flag. And usage recording is behind the other experimental flag, which is the record use. The tree shaking itself is currently in active development. As Moritz said, it works on Linux, and it works in Dart, but not in Flutter. So that's the kind of the state there. And data assets is also in development. It's a stack of CLs that hasn't been reviewed and landed yet. And then we have some future plans that kind of tie into this whole idea of having hooks. So for example, there's a Flutter doctor. It tells you if you have like the right native toolchain installed. Like it tells you like if you're on macOS and you have not installed the Android NDK, it tells you like, hey, you don't have the Android NDK installed, you cannot compile for Android. So with this like step where we have like arbitrary scripts that can compile code, any package might need different tool chains, right? So the one package might require the C compiler, while the other package might require a Rust compiler, and the third package might require a Go compiler. You name it. Maybe even some people want to, I don't know, compile OCaml or Haskell, or I don't know what you want to come up with. Now, it would be very painful if every time you try to use such a package, it would just fail the hook, and you get some kind of error message, and it says like, hey, okay, it failed because you don't have a Rust toolchain. And then you have to go look in the documentation of that Rust toolchain, like of that package, how to install the Rust toolchain. So what instead we would like to do is like add another hook, just not a build hook and a link hook, but a doctor hook that can communicate for every single package what are the required dependencies. And then if you do Dart doctor, or maybe in the future Flutter doctor, it will not only tell you dependencies for Dart and Flutter itself, but also for all your transitive packages. And in general, more hooks, because that enables more functionality. One thing that I would like to ask you is to contribute. And there's a couple of ways of doing this. First one is try it, break it, and report it, because then we can make it better. And the better it is when it gets out of experimental, the better it is. If you want to be actively involved, you can come to our issue tracker and discuss on the open issues, brainstorm solutions, and like, oh, maybe we could use this. Because, to be honest, I don't know that much about Windows toolchains. So if you want to come and tell us what we should do for linking and tree shaking on Windows, that would be great. And if you have a lot of time on your hands and you like coding, which if you're Flutter developers, you probably like coding, come and implement some stuff. We have a bunch of open issues where we are open to contributions. Implement it, write tests, send a PR, and then we will reward you with lots of heart and rocket emojis. And for the people who are already actively contributing, maybe you might know some of these. These are some people that have already actively contributed to this effort. So I just want to give them a shout out. Thank Matai, Chandler, and Gabriel. And there's probably some people I'm forgetting. So yeah, come and see us on the issue tracker. It's dartlang/native. That's where like all the code lives that is like shared between Dart and Flutter, and not part of Dart and Flutter, because we need a place for sharing code. So that's where we're tracking most of these issues, and that's also where all the other interoperability issues are being tracked for FFIGen, the tool that you saw, and JNIGen if you want to have Java interop. Is there more slides? No, thank you, slides. Thank you.